Hi everyone, this is your host TCW. In this video I'd like to introduce you to the concept of nested loops. This concept is very powerful but sometimes a little hard to understand how to implement it in animation nodes. I hope this video can help to make things a little bit easier for you. I'll extend the node tree from the previous video on animation nodes loop basics with a nested loop. Before we start to extend the node tree, let's look at the final result which we should get at the end of this video. In the 3D viewport on the left you see the set of curves of a linear function that are displayed with different colors. In the animation nodes editor on the right, I added some frames to clearly identify the different parts of the node tree. On top you see the frame labeled inner loop definition. This in fact is the loop that was created in the previous loop basics video. Below this you see the outer loop definition, which contains the execution of the inner loop. It's the node at the center of the frame which has the same color as the nodes of the inner loop definition. Now in the third row from above you find the frame with the execution of the outer loop. At this point we can see a primitive way of displaying the vector lists that are generated by the loop. To create a better display, the vector lists are transferred to the display loop execution nodes. This is a way of cascading loops. And on the bottom there is the frame with the display loop definition, which generates the colored function graphs with the colors automatically arranged in a color gradient. Before getting started, let me give you a little advice. First, I often was confused and thought something was wrong with my node tree. But actually the node tree just suddenly stopped working without that I noticed that. By default, the animation node's node tree auto execution is set to always. This is fine for smaller node trees, but as node trees get larger, the always auto execution option often gets disabled at some point. If you don't have the other options activated, the node tree stops from being executed. If you don't realize that this has happened, you may end up looking for problems in your node tree where there are none of them. To avoid this, I highly recommend to enable the options tree changed, frame changed and property changed for the auto execution right after you created the node tree. This can be done in the right side panel on the node tree tab by expanding the auto execution section and checking the checkboxes of the options I mentioned before. This will suit for most applications and you can execute the node tree manually at any time by pressing the Execute Node Tree button in the Animation Node Tree section. But now let's start to extend the node tree from the Animation Node Loops Basics video and let's see how to build the entire node tree. To concentrate on the node tree, to keep things short and to have a structural guideline, I prepared a Blender project with the empty frames from the results preview we've seen before. The inner loop definition called Vector List Generator is ready to use, and to start the outer loop definition we just need to integrate the invoke node of the inner loop. So I add another loop node, put it into the respective frame and call it param loop. Now I add the invoke node to the frame for the execution of the outer loop. I decided to add float lists with the sets of parameters to apply as iterators, so it does not use the default iterator as the inner loop. Just let me connect the slope and the offset socket of the inner loop invoke node to the new iterator socket of the loop node of the outer loop. So the appropriate sockets are automatically added with the corresponding data types. They also get the label from the socket that is being connected. To avoid having to enter the sets of parameters manually, I want to use float range nodes to generate them automatically. So let me add 2 of them to the node tree and connect them to the float list socket. To keep the amounts of both parameter lists equal, I connect them to an integer input node where I can adjust the number of parameter sets and thus the number of curves. I also think that it's practical to expose the default iterator of the inner loop to the outer loop, so it can be easily changed. Because this value should remain constant during the iterations, I'll expose this as parameter of the outer loop. So just connect the iteration socket to the new parameter socket. And this is also added automatically. Now that we have exposed all iterators and parameters, it's time to add the outputs we need. To show all values with a 3D viewer, it's sufficient to generate a single vector list output. If I add a 3D viewer and connect it to the invoke node of the outer loop, you see the values of the different curves. But as the number of curves increases, it gets hard to distinguish the set of curves. To generate a display with curves that are assigned to each single curve, we need a list of vector lists. One vector list for each curve. So let me add a generic list output. As we'll see later on, we can extract the single vector lists by using a convert node. So let's build the display loop definition now. Let's add another loop node and give it a decent name like create spline meshes. I decided to create splines from points and give them different vertex colors for each curve. Because vertex colors only work on meshes, I have to convert the splines to meshes. So we need a generic list iterator and an object list iterator. Let's call it list of vector lists and spline mesh targets. Now I add a convert node, connect it to the generic iterator and set it to vector lists. By adding a spline from point node, I create a spline from the vector list we extract from the generic list of vector lists. Add a mesh from spline node to convert it to a mesh and connect it to an insert vertex color layer node. Finally, we need a mesh object output node to display the objects in the viewport. To create the color gradient, I add a combine color node and switch it to HSV. Set S and V to 1 and connect the color output to the color input of the insert vertex color layer node. I now add a map range node and connect the value output to the hue input of the color combine node. Then connect the loop index to the map range value input and the loop iterations to the input max socket. This will automatically create a hue value from 0 to 1. To execute the display loop, let me add the invoke loop node to the execution of display loop frame. I now have to connect the generic list output of the outer loop execution to the generic list input of the display loop execution. To generate the target objects, I add a mesh object output node, check if the type is set to mesh, and add a target object by clicking the plus symbol. Now I add an object instancer node and connect the source input to the mesh object output node and the object's output to the spline mesh target list input of the invoke node of the display loop. To tell the object instancer node how many instances are needed, I place a reroute socket on the connector that transfers the generic list and connect it to the instance's input. Animation nodes automatically generates a getLength node. To have the vertex colors shown in the viewport, the material has to be modified slightly. You need to set the base color either by using a vertex color node or an attribute node. I'll use a vertex color node here. Therefore, we switch to the shader editor, add a vertex color node, and connect the color output to the base color input of the principled BSDF shader node. Select the vertex color name and you're done. Of course, you can display other mathematical functions as well. Maybe it's helpful to adjust the value range and steps and to adapt the parameter assignment. This could look like this extended example with a set of sine wave curves. I hope you enjoyed this video. Thanks for watching and stay tuned to another video on this channel.